Hi everyone, welcome back to my math tutorial video. Today I'm going to talk about long division of polynomials. So usually when we try to solve for polynomial long division problem, we always start off having a fraction of polynomials. That's one polynomial over another polynomial. And normally, for the most of the time, the highest power of the upper polynomial is bigger than the highest power of the lower polynomial. So the reason is pretty similar to converting a fraction into a mixed number. So for example, if the numerator is bigger than the denominator, then we can convert that into a mixed number, which is a whole number plus a fraction, right? However, if the top is already lower than the bottom, or the smaller than the bottom, then we don't need to do anything, right? We can just copy it. So there's no point to do the simplification using the long division or something. So same thing here for the polynomials. So here we're going to use the quotient rule of exponents. We have x to the power of a over x to the power of b is equal to x to the power of a minus b. And for long division, we always have a is bigger or equal to b. If a is smaller than b, then it's no point to use long division. So there are 3 steps for applying the long division. So we want to simplify this fraction of polynomials by using long division. So here we will have a long division sign here with the dividend, divisor, and the quotient, and also the remainder. So our polynomial a is going to be our original dividend, right? And then the polynomial b is our divisor. And we are going to have a quotient, and then remainder as well. So our first step is divide. So we divide the first term of the dividend by the highest term of the divisor. So basically it's just the first term of polynomial a divided by the first term of polynomial b. And then we keep the result at the quotient section here. And the second step is multiply. So we multiply the divisor by the result from step 1, which is the result at the quotient section here, and then write down the result below the dividend. So here, whatever we got from the step 1 multiply by the divisor will give us new result that we're going to write it down below the dividend, the original dividend. So here we will have a q multiply by divisor, right? And then over. So number 3 is subtract. So we subtract the result from step 2, which is q times divisor here, from the original dividend to get the remainder. So here we'll have subtract here, the whole thing here. So we have polynomial a minus the quotient times the result times the divisor, and then we will get the remainder, right? And then it's just repeating the previous 3 steps. So it means that we're going to have this remainder as our new dividend, and then we divide the first term of this remainder by the first term of divisor again. And then we're going to have another result at the quotient section, and then keep repeating until the highest power of the remainder is smaller than the highest power of the divisor. Then we stop. It sounds a little confusing, but let's just try a warm-up problem to explain the process. So now we have negative x to the power of 3 plus 4x squared plus 2x minus 6 over x squared minus 2x plus 3. So this is our polynomial A, this is our polynomial B. Now let's do a long division. So here we will have our polynomial A as a dividend. So it's negative x to the power of 3 plus 4x squared plus 2x minus 6. And then divisor will be polynomial B. So we have x squared minus 2x plus 3. Okay, so our first step is divide. So we find the highest power, which is 3 here, which is the first term of polynomial A, divided by the first term of polynomial B. So we have a negative x, right? Our second step is multiply. So now we have the result from the first step multiplied by the divisor. So now we have a negative x times x squared. So we have negative x cubed. And then here is negative negative, so plus 2x squared. And the last term is negative 3x. So our third step is subtract. So we're going to subtract the result from step 2 from the original polynomial A, the dividend. So the original dividend, polynomial A. So now we can cross out the first term because they are the same. So we have a 0 here. And this is 4 minus 2. So we have 2x squared. And this is 2 minus negative 3. So we have 2 plus 3, which is 5x. And then here's 0, so we just copy it down, minus 6. Okay, so now we have a new dividend, which is 2x squared plus 5x minus 6. And then we go over the same process. So now divide again. So now we have 2x squared divided by x squared. We have 2. And then multiply. So it's 2 multiplied by that. So we have 2x squared minus 4x plus 6. And this is subtract. So now here is also 0 since they are the same. And this is 5x minus negative, which is 5 plus 4, which is 9. And this is minus 6 minus 6, so it's negative 12. So now the highest power here is just 1. This is the power of 2, so we stop here. Okay, so then the final answer would be equal to negative the quotient first, so it's negative x plus 2 plus our remainder here is 9x minus 12 divided by polynomial B, x squared minus 2x plus 3. Okay, and this is pretty straightforward, and we follow step by step. It's better to make the same power of x aligned up here by column. So it's easier for us to to double check and also to track our result. Okay. So let's do another example. And this is more complicated than previous one. So now we have the power of 6 and divided by the power of 3. So again, we do the long division. We copy down the polynomial A as dividend. So here we have x to the power of 6 minus 6. So here we will see that there's a 1 power skipped, which is the third power, right? So it's better to keep the power of 3 with the coefficient of 0. So we have 0x cubed plus 7x squared minus 6. Okay. And here our divisor is polynomial b, x cubed minus 2x squared plus 3x. And don't forget to recall the 3 steps. The first one is divide. And the second one is multiply. Third step is subtract. Right? Okay, so first is divide. So here is the power of 6 divided by power of 3. 6 minus 3, which is x cubed. And now we multiply that. This is going to be the same as x to 6. And here is minus 2x to the 5th plus 3x to the 4th. And that's it. And now we subtract everything here from the original dividend. This is going to be 0. This is going to be 4 plus 2, which is 6, x to the 5th, minus 3, so it's minus 5, x to the 4th. And then we copy down the rest, which is 0, x cubed plus 7x squared plus x minus 6. And then we go back to the first step, divide. So now we have x power of 5 divided by power of 3. We have a 6. Here would be x squared. And here, second step is multiply. So 6x to the power of 5. And then subtract. Subtract here is 0. This is negative 4x cubed. And 7 minus 21 is minus 14x squared. And then we copy down the x in the minus 6. And the last would be here the same power now. This is going to be a constant, so it's negative 4. And this is negative 4x cubed plus 6x squared minus 12x. And then we'll subtract that from the previous polynomial. So the first term is always 0. And here is negative 14 minus 6, which is negative 20x squared. And 1 plus 12, which is plus 13. And here is the negative 6. And now the highest power of the remainder is only 2, which is smaller than the highest power of divisor. So now we stop here. So we have our quotient, our remainder. So the final answer would be copy down the quotient here. So we have x cubed plus 6x squared plus 7x minus 4 And now is the fraction part. So we have negative 20x squared plus 13x minus 6. It's all over x cubed minus 2x squared plus 3x. So that is the final answer. Yep. I think this long division is not complicated, but you gotta be careful because sometimes you might miss a power, like here, power of 3 here, and sometimes you will mess up with the power. So it's better to keep consistent, so it's all the same powers, so aligned up, and it's easier for you to track the final result. If it is very large power here, you're going to be a longer process than the one I showed here. Okay, so I think that's pretty much for today, and if you have any questions, just leave a message with a comment, and I will see you guys in the next video. Thank you for watching.